Welcome to ScienceCover.com. First, let's complete the Do Now task. Pause the video and see if you can answer the questions on specific heat capacity. Let's check our answers. Write the definition of specific heat capacity. The specific heat capacity is the amount of energy required to raise the temperature of 1 kilogram of material by 1 degree Celsius. How much energy will it take to raise the temperature of 2 kilograms of water from 10 to 50 degrees Celsius? Take the specific heat capacity of water to be 4,200 joules per kilogram degree Celsius. Energy is mass times the specific heat capacity times the temperature change. So this is 2 times 4,200 times 40. This gives us 336,000 joules. In today's lesson, we are going to be looking at power stations and non-renewable fuels. We shall explore how do we make electricity, what are renewable and non-renewable fuels, what is a fossil fuel, and what are the advantages and disadvantages of non-renewable fuels. Electricity is at the heart of today's modern society. Power in our homes, our offices, our cinemas, our shops, and our mobile phones. We've become dependent upon it for the way that we live. Where does electricity come from and how is it made? Around the magnet there is a magnetic field. If we move a wire through this magnetic field, or move the magnet past the wire, then it forces the electrons inside the wire to move, creating electricity. Moving the magnet in the opposite direction forces the electrons to move in the other direction. Moving the opposite pole of the magnet over the wire also causes the electrons to move in the other direction. So to make electricity, we must move a magnetic field over a coil of wire. A power station is designed to do this on a large scale. The power station has a section called a generator, where a large coil of wire is spinning past a large magnet. Let's have a look at how a power station works. We'll start from where the electricity leaves the power station. This section is called a transformer, and the transformer's job is to raise the voltage. The electricity comes to the transformer from a generator. The generator is the magnet and the coil of wire, and the coil of wire is spinning past the magnet, producing the electricity, which is then passed to the transformer. To get the coil of wire to move, we require a turbine. A turbine is a blade that is rotated by steam passing over it. Now to get steam, we require a boiler. A boiler is going to heat the water, and the water is going to become steam. The steam is then going to pass over the turbine, turning the turbine and spinning the coil inside the generator. But to create the heat to turn the water into the steam, we require a furnace. Well, the furnace will burn either coal, oil or gas, and the heat that is released will be used to turn the water into the steam will spin the turbines, the turbine will spin the coil inside the generator will then pass that electric current to a transformer, and the transformer will raise the voltage so that it can be carried long distance. Pause the video and complete task 1. Let's have a look at the answer to task 1. The missing sections were the boiler, the turbine, the generator, and the transformer. The job of the furnace is that a fossil fuel is burned to produce heat. A boiler contains water which is heated to steam. The turbines, the steam is moved over large blades causing them to rotate. The generator is a large coil that is rotated past a magnet, and the transformer is the voltage is increased before the electricity is transmitted. The faster we can rotate the coil in the generator, the more electricity we can make. So we need to spin the turbine as fast as possible, which means we need to make a lot of steam. To produce steam, we need to burn a material that will release lots of thermal energy. For this, we use fossil fuels. There are 3 fossil fuels: coal, oil, and natural gas. Let's look at where fossil fuels come from. Millions of years ago, there were plants and animals alive, much like today. When some of the living organisms died, they became buried in sediment, either in river basins or swampland. Over time, layers of additional sediment were laid on top of the organisms, crushing them and producing heat and pressure. After millions of years, the heat and pressure will turn the organic materials to coal, oil, and natural gases. We call these fossil fuels. We can dig or drill to get to the fuels, which are deep underground. When we burn the fossil fuels, they release large amounts of heat. One of the biggest issues with fossil fuels is that they're non-renewable. A renewable resource is one that can be replenished as it is used. The wind will turn a turbine, but moments later it will still be blowing. The sun will shine on the solar panel, but moments later will still be shining. They are being replenished as they are used. Generally, a renewable source is one that can be used over and over without running out. But a fossil fuel like coal, once we burn it, it is gone. There is no more coal, and we would have to burn another piece of coal. In this sense, fossil fuels are non-replenishable. They are non-renewable, and one day they will run out. Now pause the video and complete task 2. Let's have a look at the answer to task 2. Millions of years ago, there were plants and animals alive, much like today. When some of the living organisms died, they became buried in sediment, either in river basins or swampland. Over time, layers of sediment were laid on top of these organisms. Over millions of years, heat and pressure from the sediment above changed the organic material into coal, oil, or natural gases. We call these fossil fuels. When we burn a fossil fuel, they release heat. A renewable fuel is one that can be replenished as it is used. However, it takes millions of years for fossil fuels to be created. They cannot be replenished. Therefore, fossil fuels are classified as non-renewable. So the missing words are millions, sediment, heat, gases, fossil, replenished, non-renewable. Let's have a look at the answer to task 2b. The renewable sources were wind, water, and solar. The non-renewable sources were coal, oil, natural gas, and nuclear. Fossil fuels are incredibly useful to us. They release a lot of energy when they're burnt, which means that we get a lot of heat and can create a lot of steam and electricity. The power stations can be started up quickly in a few hours so they don't need to be on all the time, but they can be used to meet peak demand. The disadvantages of fossil fuels are the gases that they release when we burn them. Fossil fuels contain carbon, so when we burn these, the carbon bonds with oxygen in the air to create CO2. CO2, or carbon dioxide, contributes to the greenhouse effect and may be causing the Earth's climate to change. A lot of fossil fuels also contain sulfur or nitrogen compounds. When these burn, they form sulfur dioxide and nitrogen dioxide, which pass into the atmosphere and mix with the clouds, forming sulfuric acid and nitric acid, which fall as acid rain. All of these sources are non-renewable, and that means that they will one day run out. Now pause the video and complete task 3. Let's have a look at the answers to task 3. Burning fossil fuels produces CO2, which is a greenhouse gas, and will cause climate change. Burning fossil fuels produce lots of heat, which can be used to heat water quickly into steam. Fossil fuels are difficult to access as they are buried under the ground. To obtain them, we must dig deep into the ground by building a mine. Fossil fuel power stations can be switched on and off in only a few hours. Building a power station creates jobs in the local area and bring money into the region. Fossil fuels contain nitrogen and sulfur, which when burned become nitrogen dioxide and sulfur dioxide, which mix with the clouds to produce acid rains. In the 1950s, developments in atomic science led to the development of nuclear power stations. These use heat from radioactive elements like uranium to heat water into steam. Because nuclear fuels don't burn any fuel, they do not produce any carbon dioxide and therefore do not cause climate change. They also do not produce sulfur dioxide or nitrogen dioxide, so they do not produce acid rain. Nuclear fuels produce large amounts of electricity from just a small amount of fuel. A nuclear power station, however, takes a long time to start up, several days, and this means that it's no good for meeting a boom in demand. However, once running, it will produce a large amount of electricity consistently and can make up the backbone of a country's power grid. Anything radioactive that needs to be disposed of is called radioactive waste. Once the fuel rods run out, the rods are still highly radioactive. This means that they have to be disposed of by encasing them in concrete and storing them in vats of water. This is dangerous and costly. If a nuclear power station's fission process is out of control, it creates huge amounts of heat. This has caused a meltdown, and it can cause the reactor to explode or throw radiation into the air, or melt the radioactive fuel into a molten form, which can then sink deep into the ground and into the water supply. This is what happened at Chernobyl in 1986. Now pause the video and complete task 4. Let's have a look at the answer to task 4. Firstly, we must decide which category the answer falls into. An answer that contains at least one advantage or one disadvantage but doesn't give too much information, is 1 or 2 marks. 3 to 4 marks, the answer must contain at least one advantage and one disadvantage, or several advantages without giving a disadvantage, or several disadvantages without giving an advantage. To score 5 or 6 marks, the answer must contain more than one advantage and more than one disadvantage, and give an opinion based on the evidence. So the advantages for nuclear power stations are that they produce a large amount of energy from a small amount of fuel. They produce consistent and reliable amounts of electricity. They're cheap to run once they've been created. They don't produce CO2 or lead to climate change. And they don't produce SO2 or NO2 or lead to acid rain. The disadvantages are that nuclear power stations produce nuclear waste, which is highly radioactive. Nuclear power stations can take a long time to start up, several days after they've been switched on. Nuclear power stations are difficult to decommission as they require a long period of time before the level of radiation falls. And that nuclear power stations can overheat, leading to a meltdown.